Hey, we just wanted to give you guys a hint on Schoology 8.2 problem number 7. So what this problem is looking at is, say we had a beaker of water, we throw some of the sodium chloride in there, and we know it's going to dissociate into sodium ions and chlorine ions. There's some energy associated with that. So that's what it's asking about. What is the change in the heat of the solution? So we have a 150 milliliter sample of water that loses 5.60 degrees Celsius when we add 52.5 grams of sodium chloride. So if it's a delta H solution, we're looking for kilojoules per mole is any delta H. Okay, so we get that from Q equals MC delta T for the heat energy. We know that's going to be joules. We'll have to convert it to kilojoules later. So the mass from Q equals MC delta T comes from, we have 150 milliliters of water and we have 52.5 grams. Remember, 1 gram of water is equal to 1 milliliter of water. So therefore it's 150 grams. So we get 150 grams, 0 grams of water plus our 52.5 grams of the sodium chloride gives us 202.5 grams total. Specific heat of the water is 4.18 joule per gram degrees Celsius, right? So that's the amount of energy it takes to raise 1 gram of water 1 degree Celsius. And we're using water because it has a high specific heat. And really, that's what's changing is the temperature of the water. So the delta T, we said, was equal to negative 5.60 degrees Celsius. So Q equals 202.5 grams times our 4.18 joules per gram degrees Celsius times a negative 5.60 degrees Celsius. Grams cancels out grams, Celsius cancels out Celsius, and we end up with significant figures 4740 joules. Why did I drop the sign? The sign gives us information, but in the end, we need to decide, is this endothermic or exothermic to give it the correct sign? And we'll go over that. So we're in joules. We need kilojoules per mole. So delta H solution, kilojoules per mole. So we need to make this 1, 2, 3. We divide by 1,000. There's 1,000 joules in 1 kilojoule. So 4.74 kilojoules per. And where do we get the moles from? We get the moles from sodium chloride. So 52.5 grams NaCl, grams of NaCl into moles of NaCl. Number 1 mole, 58 grams. And you can do the work. We find that, plug it in here, and you're going to end up with the kilojoules per mole. So this last part, endothermic versus exothermic. So we started out with water in the cup. And when we added the salt into the cup, the solution was formed. The water lost negative 5.60 degrees Celsius, right? It lost heat. Where did that heat go to? The heat went into making the solution. So it went from the water into the solution. That would be endothermic in terms of the reaction. So for every heat loss, there's a heat gain. It's just a transfer of heat. So the water loses the heat. It goes into making the solution. So this is going to be a positive kilojoules per mole because it's endothermic.